All right, Algebra 1 students, welcome to your 7.2 notes on multiplying powers with the same base. The big idea here is that if you have the exact same base, you can take powers that you're multiplying together and basically just add them together. This is a visual of what's going on here. 3 to the 4th is really 3 times 3 times 3 times 3. And 3 to the 3rd is really 3 times 3 times 3. So you really have 3 to the 7th here. And so this is a visual for you on how that works and why that works. And little review for some of you, 3 to the negative second power is really 1/3 times 1/3, and then 3 to the 5th power is 3 times 3 times 3 times 3 times 3. So you have 3 to the negative second power plus 3 to the 5th power. And I said that wrong again. You're basically adding these powers together. You really have 3 to the negative second power times 3 to the 5th power. All right, so in general form, basically what that is a to the m times a to the n is equal to a to the m plus n. And there we have it. So let's take a look at a couple of examples here. So for number 1, we have 7 to the 5th power times 7 to the 3rd power. So what I'm going to do is add those two powers together. And I end up with 7 to the 8th power. I'm not going to calculate that one out for you, but I would encourage you to do so. It's 7 times 7, and you just do that 8 times. All right. So for number 2, we have x to the negative 11th times x to the 6th power. So folks, this is x to the negative 11. Come on. Plus 6 up here, and then we end up with x to the 5th power. All right, don't mix up where you're going on the number line there. A lot of you like to mess up your negatives there and do something like negative 17, or you'll do just 17 there, and so some of you forget that you've got a negative there. I know that's a problem for a lot of you. Some of you, you've got that down. All right, so for number 3, we've got 6 to the negative 3rd power times 6 to the 5th power. So I'm going to add those exponents together, and I end up with 6 squared. All right, and I can calculate that one without a calculator. I've got 36. All right, and for number 4, we're going to add those two exponents together, and we get x to the 11th power. All right, on to the next slide. All right, for number 5, folks, when we do this one, I can break this one up a little differently than the way that they have this broken up. I can actually break this up into x squared times x to the 3rd times y squared. All right, y times y squared. So when I do that, I can basically add those exponents together now that I've got them kind of grouped differently. And so I have x to the 5th times y to the 3rd. All right, all I'm really doing is taking the same base there and adding the exponents together with the same base. So let's do that again here with number 6. So I've got x to the negative 2 power times x to the 5th power. I'm just going to rewrite that like that. And then I've got y to the 3rd times y to the negative 2 power. And again, I can add those exponents together. Let's clean that up a little. Well, let's just start over with that one. I can add those exponents together, and I get x to the 3rd power y. Well, y is going to be the 1st power, so I'm just going to leave it as y. So x to the 3rd y. All right. All right, so in number 7, we're basically just trying to figure out what number would go right here to make this equation true. And so 16 minus 9, well, that's going to be 7, so it's really 7 to the 7th power right there. So that's what we're looking for there. We're just trying to complete that equation to make it true. If you were to add 9 and 7 together, you'd get 16, and so that's the idea there. Number 8 is asking us the exact same thing. So in number 8, I'm going to have a negative 5 right there for that x, because then my x's are going to basically cancel each other out. And then I need to have y to the 5th right here, and then I would have 5 plus 1 would equal 6. So that's how I would complete number 8 there. All right, so for this slide, for number 9 through 12, and really just with scientific notation in general, there's a big idea here that I want to make sure I point out to you. You have a times 10 to the b power, and this is basically how you can state a number that's either gigantic, or super duper duper small. All right, so you have to have this first number, this a value, has to be between 1 and 9. It cannot equal 10. All right, so hopefully you guys understand our inequality there, our compound inequality there. A has to be an integer, basically. Okay, so you cannot, in fact, I said that wrong. A cannot be an integer. Sometimes because you're going to have a decimal point, and that's the whole idea of scientific notation. But basically, you want to have a number there that's basically just got one place value in front of the decimal for the a. Okay, so let's take a look at a couple of examples here. Let's count how many places I would need to move the decimal for number 9, and that's how many place values we're going to put in there for b. So I start right there with my decimal, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so this one's going to be 4.326 times 10 to the 10th power. And that's how you would write that number in scientific notation. Hopefully that's a little bit of review for you, but we're basically going to do a little bit of review on this because in our next slide we're going to have to figure out what to do when we multiply them together. So number 10 has us go in the other direction. So we've got a decimal, and we're going to go 1, 2, 3, 4, 5 spots. So in this one, we're going to have 4.1 times 10 to the negative 5th, because we had to go to the right in order to state that number. And let me recount my decimals there, because something on my screen came up that I didn't want. So I've got 1, 2, 3, 4, and 5. All right, that looks good. So write the number in standard form for number 11 and number 12. We're going the other direction. So I'm going to take 8.2. So I'm going to write 8.2, but I'm not going to write my decimal point yet because I'm going to go 1, 2, 3 spots. And so this number would really be 8,200. And again, in number 12, I'm going to go the other way again. I'm going to say 371. I've got my integers there. And on this one, I'm going to go negative 7. So that means I'm going to go to the left 7 spots. All right, so I'm going to say 1, 2, 3, 4, 5, 6, and 7. So I'm going to go way over there. So that means I would need to add in all of these zeros. And then my decimal point would go right there. Probably could have given myself a little bit of extra space there. But I think you guys get the picture. Okay, so in number 13, I'm going to rewrite this problem just a little bit. I'm going to have 4 times 2, and then over here we're going to multiply that by 10, and then we're going to use our exponents rule of 3 plus 5 over here in our exponent. So what we end up with for our scientific notation is 8 times 10 to the 8th power. All right. Didn't realize our example was going to have all those 8s in it. But there we go. All right, so number 14, we've got 6 times 7, so you're going to have 42. And then you're going to have that multiplied by 10 times 10 to the negative 5th times 10 to the 8th. So you would add those two exponents together. All right, so we're going to really have 42 times 10 to the 3rd power. Okay. All right. So, in number 5, I'm going to have 0.3 times 1.4. So I'm going to think about that as if I've got 14 times 3. And so if I had 15 times 3, well, that'd be 45. And it's 14, so it's going to be 3 less than 45. So I'm going to have 42. But it's a 4.2. All right? The other way you could think about that is 3 times 1, which would be, or 3 times 10, which would be 30, and then 3 times 4, which would be 12. You could add those together and just move your decimal point just a little bit. And then I've got 10 to the 8th times 10 to the 5th, so I've really got 10 to the 8th plus 5th up there. And so I've got 4.2 times 10, and that's going to be the 13th power. All right. And folks, that's the end of your notes for today. Come to class ready to work diligently.